and welcome to my talk on breaking down the user monolith. I'll be your guide in demonstrating some techniques that I've used recently in taking a larger user domain model and breaking it down into smaller focused modules using the Elixir programming language and Elixir's flagship database library, Ecto. But let's start with a quick show of hands. How many of you have modeled users in an application? Well, that's good, we're in the right place. And now, how many of you felt like your user domain model is doing too much? All right, great. So over the course of this talk, I will demonstrate 3 techniques that you can use to break down a larger user module into smaller discrete components, and hopefully convince those of you who didn't raise your hand for the second question to try these techniques out. Before I share those techniques, allow me to provide a little context around who I am and what my experience is as a software engineer. My name is Zach Porter, and I have been building web-based software for the past decade, with the bulk of that experience using the Ruby on Rails framework. And while I'd like to take credit for this handsome illustration of myself, my daughter actually did this rendition, and she was not able to fly out west with me. But this was my way of bringing her with me to the talk. My background, since coming from Rails, if you all here are familiar with Rails, or even if you're not, within the Ruby on Rails framework, it uses a pattern called the active record pattern. And essentially what that is you have one Ruby class tied to one table in the database, and instances of that class are mapped to a row within that table. So as an example, on the left here, I've got a pretty typical Ruby class named user that inherits from application record, and with a list of its implicit attributes from the database within the comments there. And then on the right side, we've got an example of the schema from the database. And this one-to-one mapping of class to database table quickly leads to kind of a lot of responsibility and functionality being placed on that one class. And so what we do in the Ruby community is when we go to isolate that functionality, we kind of group it together into little Ruby modules or mix in and then include it into the class. We in the Ruby and Rails community have built libraries to help with this common pattern of account management in an application. One such library that I'm most familiar with is Devise. Devise abstracts all that account management functionality into one method call on our class. But that only hides the fact that our user class now has hundreds of methods spanning multiple responsibilities, which in my years of experience has taught me that that approach is not sustainable over the long term. Making a minor change to a piece of functionality can result in my opening several Ruby files to try to piece together where exactly I should make the change. As I came to Elixir, I brought that experience with me. My first real-world application in Elixir is a web-based learning management platform that allows users to shop and purchase access to an online course. As an example for this talk, and taking inspiration from the wonderful community that we've gathered here, some examples of online courses that users might be able to purchase could be Learn You Some Haskell for a Great Good or Learn You Some Erlang. So for the rest of this talk, I will refer to this application as Learn You. Learn You began life as a Phoenix 1.2 application. For those in need of a quick history lesson, Phoenix 1.2 provided a top-level lib directory as well as a top-level web directory. I looked at the web directory the same way that I looked at Rails' app directory, since Phoenix laid the foundation of having a web models, web controllers, web views, etc. I placed all of the domain models from my application into the web models directory. So as you can imagine, there was a web models course.ex that mapped a course schema to a courses table in the database, an order.ex that mapped an order schema to an orders table in the database, and for the main focus of this talk, a web models user.ex that mapped a user schema to a users table in the database. My user module consisted of a large ecto schema definition, and as well as its associated functions to manage various different change sets. If you're not familiar with some of these terms from ecto, schemas map fields from any data source into Elixir structs. Typically, these are from a database, but as you'll see later on, they don't have to be. Change sets provide a way to filter and map external parameters, such as from a form on the web, to an Elixir struct, as well as a mechanism to validate and track changes before they are applied to the data source. Upon initial launch, my user schema was quite large. At first glance, this can be overwhelming. Once the time has been taken to read all the fields, however, you might be able to piece together how each field is used, but confidence in that might be pretty low still. An easy win we can achieve with a large schema such as this is to group related fields together by functionality and just add a little comment naming the functionality. This will help a future reader, such as myself 3 months down the road, quickly parse the fields in the schema and understand their purpose. There is another benefit, however. Now that we've grouped fields like this together, and given them a description of the functionality they belong to, we can actually take those fields and move them from this larger user module to a specific module of their own. So as an example, let's take the fields for confirming a user's email address. We need a token to identify the account from a link that the user clicks on in an email that we sent them, as well as a couple of timestamp fields to track when the email was sent and when the link was clicked. This is a fairly standard confirmation flow. I'll create a module named confirmation, and in it, I'll define an ecto schema with the user's email, so we know where to send them to, the confirmation token, confirmation sent at, and confirmed at fields, all pointed to the users table in the database. In doing so, we can remove those fields from our user module now as they're no longer needed there, and I can do the same with the associated change set functions. Not only does this clean up the user module code-wise, but now SQL queries for that module have been made smaller. Before, a query such as repo.getUser with an ID of 1, as represented on the left side here, would have returned more columns than needed when, say, just allowing the user to edit their account information. The query on the right is much smaller and, well, a little bit smaller, not much smaller, it's a relevant query to the task at hand. I also now have a module that can grow separately should changes to confirming an email address ever come up. This change has ultimately led to less load in my head with respect of where to find and put changes with respect to confirming a user's email address. So let's look at another example with account recovery. Recovering an account or lost password typically starts with the user providing their email address associated with the account on record. The application does a lookup, and if found, sends an email with a link. That link contains a unique token which is tied to the account and for security purposes set to expire after a certain length of time. Upon clicking the link in the email, the user is presented with a form to reset their password. Back on the user schema, you can see where the fields have been grouped under the comment here. I'll take those fields and organize them into their own module named Account Recovery. Similar to what I did with the confirmation module, I'll define an ecto schema on the user's table with just those two fields. I'll also bring over the change set function, and voila! I now have an even smaller user module with less responsibility and have added another module whose sole concern is to deal with recovering a user's account. So, with these changes, I've shown how a larger user module and schema can be broken down into smaller, more descriptive modules by simply moving fields from one schema into another schema, referencing the same underlying database table. In doing so, I have lessened the responsibility of the user module, which eases the ability to read and comprehend how that module should be used. However, I have introduced this concept into the application that fields can be added to a database table for a specific piece of functionality, which, if left unchecked, could lead to duplication of data. So it's important to be aware of the underlying data and how it's being used by the application. Speaking of underlying data, let's transition into the next technique of breaking down the user module by breaking apart the underlying data. Google recently published a post on the 12 best practices for user account authorization and password management. In it, they encourage the separation of user identity and user account. Google states, your users are not an email address, they're not a phone number, they're not the unique ID provided by an OAuth response. Instead, your users are the culmination of their unique personalized data and experience within your service. A well-designed user management system has low coupling and high cohesion between different parts of a user's profile. I've highlighted low coupling and high cohesion here because this concept helps to set up the next technique very well. But continuing on with the article, keeping the concepts of user account and credentials separate will greatly simplify the process of implementing third-party identity providers, allowing users to change their username and linking multiple identities to a single user account. In practical terms, it may be helpful to have an internal global identifier for every user and link their profile and authentication identity via that ID as opposed to piling it all in a single record. Essentially, don't think of users as one table, but rather think of them as the combination of multiple tables. The push here is to separate profile information such as name, email, and phone number from authentication schemes. I can accomplish this in LearnU by updating the database to look something like this, where credentials are placed into a separate table with source and token fields. Splitting credentials off in this way allows for the flexibility of having multiple ways to authenticate with LearnU in the future. Keeping with simplicity for this talk, we'll stick with password authentication for now. The source would be set to the string password, and the token would be the encrypted value of that password. Over on the Elixir side, a new module can be created for handling credentials with a schema pointing to the new table and fields. You'll note a virtual field here for a password. This will be used later for validating user input before encrypting and storing into the token field. A reference will be added to the main user module, which can now be slimmed down by removing the fields from its schema and relevant lines from its change set functions. The change set function on the credential module will simply validate and encrypt the given password when the source is equal to password. This is looking real good. However, there's one issue. How do we tie both of these tables together on one registration form? To combine multiple schemas on one web form, one pattern that I've been enjoying leans on Ecto's embedded schemas and multi-module. Embedded schemas allow us to take advantage of everything Ecto offers through their schemas without relying on an underlying database table. I have used these to provide structure to JSON data stored in a JSON column in PostgreSQL, or for this case, bring structure to forms. Ecto Multi gives me the ability to run multiple database query operations, such as insert statements within one transaction. This allows for easy rollback should the database fail to execute all the statements. The registration embedded schema will reflect the fields on the form. You'll notice a lot of crossover or duplication between this schema and the schema on the user and credential modules. I personally can live with duplication like this because I consider them separate entities within the system. The registration process is its own domain model and should therefore have its own structure. Since the registration has its own schema, it should also have its own change set function. This change set function will cast the attributes as normal, But here you can see where I reuse some of the validation functions from my existing user module as well as the new credential module. Since they share the same fields and validation logic, I can pull this off. Now that I've shown the schema and changed that function, let me show you how I've persisted these changes in the database. Here I've added a create function on the registration module, which takes an instance of ecto-multi and parameters from the web form as arguments. From there, I use ecto-multi to run 3 functions: validation, insert to the users table, and insert to the credentials table. All of these functions are defined on the registration module as referenced by the underscore module convenience here, but they easily could live elsewhere. The validation function simply checks whether the given parameters result in a valid registration. Being a part of a multi, this function takes 2 arguments. The first is a map of changes from the ecto-multi thus far, and the second is params from the form. Ecto-multi expects either an OK tuple or an error tuple response. Here, when the change set is valid, then an OK tuple is returned, and ecto-multi takes the change set and stores it under the registration atom key in its map of changes. If the change set is invalid, then an error tuple is returned, which halts the rest of the steps to be executed within the multi and returns this change set with the insert action applied to it. Applying the action simply informs the form on the Phoenix side that it should display the errors on the form from the given change set. The insert user function should look familiar to anyone with ecto experience. It builds a change set based on the parameters from the form and attempts to insert the record into the database. This function executes only when the validate registration function returns a successful response. And I'm leaning on the repo.insert function here to return either an OK tuple on success or an error tuple on failure. Ecto-multi handles that response in the same way with storing the user struct in its map of changes on success or returning the user change set with errors on failure. The insert credential function is the last step in the multi-run and is responsible for inserting a record into the credentials table. If either steps prior to this resulted in failure, this function would never be executed. If this function fails, then it rolls back the prior insertion into the user's table. Again, the function takes 2 arguments, a map of changes from the ecto-multi step so far, and parameters from the registration form. The function pattern matches the user struct from the map of changes so it can be associated with the credential record. The rest of this should look similar to what we just saw, leaning on repo.insert to give us either an OK tuple or an error tuple, which informs ecto-multi how to proceed. That concludes how to provide structure, easily validate and insert the data across multiple database tables with the ability to easily roll back changes on any failure. But how does it get called from the controller with parameters from the form? Well, here I have an accounts module with a register function, which the controller action would call, and takes user input as its arguments. From there, I want to use the registration create function that I created a little bit ago, which, if you remember, that function takes 2 arguments, an ecto-multi struct and user input. The call to ecto-multi new here gives us a fresh ecto-multi struct to pass into that create function along with the params from the user. The create function returns an ecto-multi struct with the steps that need to be executed within a database transaction, which, if you remember, were validate, insert users, and insert credentials. Since this is all that needs executed for the ecto-multi within here, the next line then wraps and executes the steps in a database transaction on the repository. Once the transaction is executed, the result gets passed into a case statement where a few different results are pattern matched on and handled. The first is an OK tuple, where the user struct is extracted from the given map of changes and returned as part of an OK tuple response to this function. The second is an error tuple that matches when the registration validation operation failed. If you remember, that return value was an error tuple which returned the registration change set as a result. That registration change set is returned as a result in an error tuple so it can be used on the registration form again. The final is an error tuple, except this time that the failed operation could be either user or credential, so this ignores that value. Instead, the pattern match pulls out the change set with errors and action applied, as well as the registration change set from the map of successful changes thus far. The errors and action from the failed change set are merged into the registration change set so that it can be returned within the error tuple and used on the registration form. We can do that here because a lot of the fields are shared between user, credential, and registration modules. And that's it. If you haven't seen or used Ectomulti before, I can imagine that might have been a lot to take in. I know it took me a while to wrap my head around it, but once you get a good handle on it, Ectomulti can be a powerful tool to pull out when you want to make database record changes that span multiple tables with the ability to roll back should something go wrong. I only showed a sliver of what Ectomulti can do here, so I encourage you to go through the module docs and try it out for yourself. So to recap, so far I've shown you how to take related fields from a larger user schema and create modules that isolate the fields and change sets to make them easily testable and maintainable. I also demonstrated how to separate credentials to make from a user's profile information for looser coupling and to better set LearnU up for future expansion. I pulled in Ectomulti to help facilitate that data coming in from one registration form, validating the input with an embedded schema, and inserting it across multiple database tables. That leaves one last technique that I'd like to share with you all today. This one took me the longest to grasp coming from Rails, and I feel it's the most important for the growth and sustainability of the application code as a whole. Because LearnU is more than managing user accounts, right? If you remember back toward the beginning of this talk, I shared that LearnU began life as a Phoenix 1.2 application, which resulted in a lot of domain logic being placed in the web directory, leaving the lib directory mostly untouched. Well, all of that changed upon Phoenix 1.3's release, which brought with it a restructuring of the code. The web directory was no longer top level, moved within the lib directory. There was a big push to treat Phoenix as a web layer that ran alongside your Elixir application. I really bought into that idea and wanted to migrate LearnU accordingly. The other concept introduced in Phoenix 1.3 that I really liked is bounded context. I wanted to know more about this concept, so I ran to my bookshelf where I had a copy of Eric Evans' book, Domain-Driven Design, blew off the dust, and opened to the section where Eric explains the idea of bounded context. In it, he notes, a bounded context delimits the applicability of a particular model so that team members have a clear and shared understanding of what has to be consistent and how it relates to other contexts. I like to think of it as a practice to define boundaries around your domain models and provide a public interface to those domain models. So, as I was migrating from Phoenix 1.2 to 1.3, I started to think about the logical grouping of each of my domain models and what to name them. Has anyone here heard of or played the video game Keep Talking and Nobody Explodes? All right, we got a few hands. In this game, there are 2 to 4 players. One player is the bomb diffuser, and that person is trapped in a room with a ticking time bomb. The bomb consists of a number of modules, all of which are puzzles that need to be solved to completely disarm the bomb. The solutions to those puzzles can only be solved by working with the other players who have a manual and are considered the bomb experts. The bomb diffuser can see the bomb but not the manual, and the bomb experts have the manual but can't see the bomb. Clear and effective communication is key to disarming the bomb quickly. Now you might be thinking, Zach, that sounds super fun, but what does this have to do with bounded context and overall software design? Well, for one, they are both pretty fun, but also the modules on the BOM are like bounded contexts within an application. Each have an interface that interacts with its internals. In the case of the BOM, the interface for a puzzle could be a set of wires to cut in a certain order. In the case of bounded context, that's usually one Elixir module that serves as a public interface for the rest of the application. Each also have a set of documentation on how to use that interface. In the case of the game, that's the BOM manual, which has documentation on how to diffuse each module. In the case of bounded context, that's doc tags and type specs on each of the public functions, which document how to use a function, along with examples of use and maybe some possible return values. I like to think of bounded context as isolated modules on the BOM, with the BOM composed of many modules representing the application entirely. So back on LearnU, defining the context to define boundaries around, I landed on the following three contexts that incorporate users in some way: shop, account management, and academia. The shop context is where a customer can purchase access to courses. This context has domain models like products to purchase, a customer, a cart to put products into, and an order to capture a customer's purchase. This is by no means an exhaustive list of the domain models within this context, but hopefully gives you a general idea of the functionality that is captured within its boundaries. The account management context groups the functionality around users having an account on LearnU. It includes some of the domain models that I shared earlier, such as an account, credentials, registration. The eagle-eyed among you may have noticed that I was already nesting some of my previous examples under an accounts context, so if you did, crisp high five to you. Initially, this was probably the hardest one for me to define the domain models within because of my background with one user module and separate Ruby modules or mixins to isolate related code. What I ultimately found was that just converting what I would have in a Ruby mixin into a related Elixir module gave me a good foundation to build upon. The academia context is where a course content lives and is the heart of LearnU. Here lives the courses that are offered. Students are enrolled into a course upon purchase through the shop context. A registrar checks for enrollment when a student requests access to view a course's content. This context consists of all the things pertaining to the coursework part of LearnU. So there you have it. Three contexts that incorporate users of the LearnU platform. Shop has customers, account management has user profiles, and academia has students. Those map nicely to Elixir structs, but how can I map those structs back to the underlying users table? There are a couple of different approaches that I could take here. One way is to allow for cross-context use of one single source of truth. So as an example, a shop's orders could reference the accounts user as its customer, and an enrollment could belong to an accounts user as its student. And that's fine, but if I really want to fully embrace this concept of boundaries around my context, I want to be able to do something a little bit better. So bringing this back to LearnU, I really want the shop and academia context to be isolated from the account management context. The easiest way to accomplish this is to have a module under each context that points to the same user's database table. For the shop context, I began by defining a customer module with a schema pointed to the user's table. Since I have customer fields such as a Stripe ID and an association for orders on my user module, I can move those here under this context and remove them from the user module under the accounts context. The change set function on this module deals with setting the Stripe ID when a user's first order is placed. Once the user has an associated customer record in Stripe, then this change set is no longer called, but it's nice to have this functionality isolated under this context, where it's a little more relevant. For the academia context, there's a student module with its schema also pointing to the user's table. Here we have the associated enrollments that can be used to pull the courses the user has access to on their dashboard. I've also referenced the first and last name fields here so I can greet the user accordingly throughout their academia experience. No change set function is required, as the student is currently used for read-only data to the user's table, but that could easily change in the future as requirements for students under the academia context changes. And now we have a user module defined for each context within the LearnU application. One really cool bonus to sharing the same database table across contexts like this is that we can have a plug for loading the current user from session for each context. So as an example, since the user ID is typically stored in a session cookie, I can have a plug for fetching and loading the current user under the shop context, and it's as simple as this. The academia plug for fetching the current user can load a student from the academia context. Both of these approaches have the advantage of smaller SQL queries, which fetch only the data required from the user's table for each context. So one final recap. I have shared with you today a few techniques that I use when breaking down a larger domain model into smaller components. My specific example dealt with how users are modeled within a software application, but these techniques could be used for anywhere that you're feeling growing pains. First, I shared how to move a subset of fields into a named module that encapsulated the functionality that used those fields. The second technique dealt with splitting data up across multiple tables and how the Ecto multi-module and embedded schemas can be leveraged to bring those tables together under one form of inputs. The third technique used the concept of bounded context to share data in the database across similar domains that spanned contexts. So LearnU began with this larger user module, and after applying all those techniques, it ended with this one. More can be done here to split off the responsibility into better named database tables and associated Elixir modules, but this gives LearnU a great start to grow in the future. I've been toiling away at this for the past year or so, and I can say that it has made changes and feature development much easier than it has been for me in the past on Rails projects. So one final thought. None of the code presented in this talk is new. All of this is just building upon the established libraries and frameworks. So no matter your background or your experience, I encourage you to fully immerse yourself into the patterns that the Elixir community has established and contribute back some of your own. You may find yourself as pleasantly surprised as I was. Thanks for listening.